Structure and Bonding of Elements and Compounds, Part 1. This two-part video explains why there are only 4 possible structures that form when elements bond: molecular covalent, giant covalent, metallic, and ionic bonding. If you want to know more about each individual bond, you can click on these videos. Atoms bond if there is space in their outer electron shells for more electrons. Thus, the noble gases with their full outer shells don't easily form bonds. In an atom, the inner complete shells of negatively charged electrons are held tightly by the positively charged protons in the nucleus. However, these inner electrons will shield some of this nuclear charge from the electrons in the outer shell, which will only feel this excess charge. Thus, in chlorine, the inner 10 electrons will cancel out or neutralize the effect of 10 of the protons. So the outer 7 electrons feel an effective charge of just 7+, holding them in their outer shell. Sodium, with 11 protons and 11 electrons, has also 10 inner electrons, leaving an effective charge of only +1 to hold its single outer electron. Thus we see why nonmetals with nearly full shells hold on to their electrons more strongly than metallic elements with nearly empty shells. We also see why atoms bond. If there is a space in their outer shells, electrons from other atoms can be attracted in by this effective nuclear charge, but only until the shell is full. So let's start with the periodic table of elements, omitting the noble gases, and this last row of radioactive elements from our periodic table. Note that hydrogen, with its half-filled shell of electrons, heads up group 4, as well as being in group 1, with its 1 outer electron, and group 7, with 1 electron missing. Here are all the very reactive metals, like potassium. Here are all the very reactive nonmetals, like oxygen and chlorine. In between, the elements gradually change from being metallic to non-metallic, with some, like silicon and germanium, neither one nor the other. If we twist the periodic table clockwise and then squash it flat, we pretty much have the elements arranged from the most metallic cesium to the most non-metallic fluorine. When these two extreme elements react, they form the stable white salt cesium fluoride. We now have a triangular space where all other combinations of elements can be situated. Elements are along the top, and the space will be filled with compounds like brass, sulfur dioxide, sand, and salt. By considering the reaction between pairs of elements like this, we will show in part 2 of this video that there are only 4 types of bonding possible.